All right, today we are going to talk about how to find the lateral area and the surface area of a prism. So just to remind you from the introduction we had about 3D solids, just a prism, polyhedron with exactly two congruent and parallel bases that are polygons. And the other faces of the prism are called lateral faces. So the base is what you call in these first two examples, honestly, they have to tell you the base because any kind of rectangular prism or any kind of cube, you could really use any of the faces to be the base because it just has to be two parallel faces. So these two are kind of a special case. Otherwise, this is a triangular prism here and this is a pentagonal prism. These are the only two faces that are parallel and the same shape, and then all the other lateral surfaces are rectangles. Here, the two triangles would be the base, and again, the lateral faces are all rectangles. Okay, so as we go through here, these formulas are on the formula sheet I gave you guys, which I'm going to grab real quick and show you. So here's the geometry formula sheet. I believe the one you guys have was on a yellow sheet of paper. And so I just want to point out to you where these formulas are. This is the top of the formula sheet. So I'm just going to slide this up so you can see it's at the very bottom down here. Sorry about the glare. Let me move that up, see if that'll fix the problem. Of course not. So the lateral area and surface area formulas, if I can get that glare, they're in the bottom left corner. So if you have this at home, of course you can use those formulas for tests and quizzes, or you can use your notes too, but these formulas are available to you. All right, so let me see if I can explain the formulas real quick. The lateral area is just going to be all the rectangular surfaces except for the base. So, or bases here, since we have a prism. The P stands for perimeter of the base. And that does not give you that information on the formula sheet. It just says P times H. So you have to know that P is the perimeter of the base. And then H is going to be the height of your prism. So, let me give you a couple examples. Let me pull back up here. So let's say, remember, if I give you rectangular prism, I have to tell you which sides to use as the base. So let's say we're going to use the top and the bottom as the base. The perimeter of the base would just be around here, and then the height of the prism is the distance between the two bases. Now, let's say it was kind of laid a different way. Here's this triangular prism, so the triangles are the bases. Here I would have to find the perimeter of the triangle, and then the height in this case, the height always runs between the two bases, so if it's laid out like this, the height can go this way as well. If you're looking over here, here's the pentagon, another pentagon, so pentagonal prism here. These are the two bases, so we'd have to find the perimeter of the base, and then again, the height runs between the two bases. Okay, the only difference between surface area and lateral area is the surface area is going to include the two bases. So this is still perimeter of the base, this is still height. Now, the B here, since it's a capital letter, this stands for area of the base. And I'm going to kind of use these pictures below here to kind of illustrate these formulas a little bit. So I just grabbed this off the internet. These are just some basic prisms. So you guys can see on the paper here the bases have been kind of shaded in the net. So you got the net and then you've got the 3D solid kind of folded up so you can see it. And the lateral area is going to end up being the rectangles that are not colored in. So if you guys think about this, let me try to explain. If I fold this back up, this would match here, this would match here. So this side would end up being the perimeter of the base. So that side of that rectangle, perimeter of the base, and then the height of the figure, in this case this is a triangular prism, perimeter wraps around that base, the height runs between the two bases, and then the area there, that's just one big rectangle if I put it together, so that's why it's perimeter times height. kind of the same thing here. If we were to fold this back up, this would wrap around the base. So that's your perimeter. This would be your height. So that's how they're going to get the lateral area. And then all you got to do to find the surface area is add in the areas of the bases that you've got in the problem as well. So these are just some pictures for you guys to look at. Again, the bases are going to be the two parallel faces of the same shape. The lateral area of any kind of a prism is always all the rest of the rectangular faces. So again, these two down here, like if you folded them back up, this whole edge would wrap around. This one's an octagon. So that whole side would be the perimeter. The distance between the two bases is the height. That's your lateral area. Then to get the surface area, you have area of this base, area of this base. That's why they have the 2B, because you have two bases for your surface area. Okay, so I'm just going to practice this with you guys. So different shapes back here. The first one, I have a rectangular prism, and I don't know how well you can tell, but I kind of have this front part shaded. If you have a rectangular prism, they have to tell you what side to use as the base, otherwise your lateral area could be different. Surface area would be the same, but the lateral area could be different. So I'm going to use the front side of this. This is going to be my base because it's going to be shaded in. So all you got to do for lateral area, it's the perimeter of the base times the height. So the perimeter of the base here, this is 12, so this would also have to be 12 since it's a rectangle. This is 7, so this would be 7. This would be 7. So my perimeter of the base there would just be, add those up. So we'd have 12, 12, 7, and 7. And when you add that up, you're going to get 38. Okay, now the height runs between the two bases. So if this is a base, the backside would be a base. So the height running between them is going to be the 9. So all you got to do for your lateral area, we're just going to take 38, that's our perimeter, times our height, which is 9, and I'm literally just going to multiply that. So this would be 342. Now we're talking about an area, and I don't have a label here, so we'll have to call that units squared. Okay, now your surface area. This is your lateral area, which we just calculated, plus we got to include the area of the two bases. So I already know this part is 342. And then area of the base here is just going to be length times width, base times height, however you want to figure it out. But it should end up being 12 times 7. I have 2 of the bases, so I have that in front. So I'm going to end up with, alright, so we have the 342, that's our lateral area. And if I go ahead and do 12 times 7, I'm going to get 84. So we're going to get 342 plus 168. And our surface area then is 510. And then this is going to be units squared. Now, again, my base is shaded. This is a triangular prism. Those are the only two faces that are parallel and congruent. They've got the rectangles running between them. So I need to find the perimeter of that base, and I need to find the height. Now, the height runs between the two bases, and that's going to be the 24. So I can see that real quick. The perimeter is the tricky part here because I only have 2 sides of the triangle, but because it's a right triangle, we can go ahead and use the Pythagorean theorem. So these would be the 2 legs, and I'm going to do my a squared plus b squared equals c squared. I need that so I can complete the perimeter. So the 9 and the 12 are the 2 legs, and if we go ahead and add that up, we get 81 plus 144. Which is going to give us 225. And then we'll just go ahead and take a square root, and that's going to give us 15. So for my perimeter, 9 plus 15 plus 12, totally doesn't matter the order, you'll get the same answer either way. And this is going to be 36. So my lateral area here, perimeter is 36. The height is 24. That gives me the area of all 3 rectangles that wrap around this in one step. So this is 864. Okay, now surface area is your lateral area, plus we have two triangular bases here. Now the area of the base, different here than it was in the last question. So the area of a triangle, remember that's 1/2 base times height. If you are looking at that triangle that you have there, the base is going to be 12 and the height is going to be 9. So this is just to find the area of one of those triangles. So I'm going to get 54 here, and then all we got to do is plug it back in to get the total surface area. So the lateral area we already know from over here, plus I've got two bases, each one with an area of 54. And so when I add those together, I'm going to get a total of 972. And this one I do have a label on. Sorry, I should put that on both. It's going to be meters squared. All right, and I know I don't have directions here, but any of the prisms that we give you, or pyramids, or anything that's got kind of a little bit more complicated shape, you go ahead and assume that the base here is going to be a regular polygon. For this one, it's going to just be a pentagon. So you just go ahead and assume that's regular. That means that all 5 sides are the same length. So for my lateral area here, the perimeter of the base, each one of the sides here, if you look down at the bottom, I got a label. Each one of the sides is going to be 17. So the perimeter is just going to be 17 times 5, which is going to give you 85. And the height here is just going to be that distance running between the two bases, so that's the 38. So lateral area, 85 times 38, which is going to give us 3,230. And again, sorry, I don't have label here, so we'll just have to call it units squared. Okay, now, some of these can be complicated, some of these, it just depends on the question. This particular problem, I promise, is not bad to do. We're going to find the area of a pentagon here. So I just want to remind you, for the area of the base, this is 1/2 apothem times perimeter. Now, the apothem comes from the center of the figure to any of the sides here. In this case, it's coming to this side at a 90-degree angle. So they are giving you the apothem in the directions, or in the picture here. So this is going to be this 11.7. Now, I already found the perimeter of that pentagon over here, so I don't have to do any more work. I just have to sub this in. All right, so let me go ahead and simplify that real quick. So I'm going to do 1/2 times 11.7, that's the height, and then times the 85, that's the perimeter. So this is 497.25. Now, your surface area is your lateral area. So we already have that, the 3230. Plus, I have two bases that are pentagons here. One of the bases has the area of that 497.25. So I just got to put a 2 in front of that. And then to get the total surface area, we're going to do 3230 plus 2 times that 497.25 we calculated there. So the surface area, this is 4,224.5, and then again, we're going to have units squared. Okay, one more here, and this one's probably the trickiest. So the lateral area part is not bad. We just have, again, just go ahead and assume if you have hexagon, octagon, anything like that, go ahead and assume it's regular. So all these sides are going to be 8. So in terms of your lateral area, I just need the perimeter of the base times the height. So the perimeter of the base, 8 times 6 is going to be 48. And then the height of the prism is going to run between the two bases, that's the 12. So my lateral area is just the perimeter of the base times the height, so we're just going to type 48 times 12. This is 576. Again, we got units squared here since we don't have a label. Now, this is going to be a little bit of a throwback to our area unit. Multiple ways you could do this problem. I would recommend, if you've got a hexagon, to go ahead and use 30, 60, 90. So I don't have the apothem here. So if you guys remember, just like I mentioned in the last question, they gave it to you in the last question. I don't have it there. So this is my apothem. I need that for the problem. Now, if the side is 8, and this is a regular figure, when you drop the height there, we're going to have exactly split in half. That 8 will be 4 and 4. Okay, now I need the apothem. That's the height of that triangle. If we continue to draw all the triangles we could create here, the apothem is just the height of all the different triangles. So that's why we need that for the formula, because we just do 1/2. The base is the perimeter of the whole thing, and then the height is the apothem, and that gives us the area of all 6 of those triangles just in one step using that formula. So I'm just going to remind you guys real quick, if you don't remember, if you have a hexagon, if you take 360 divided by 6, each of those is 60. When you drop your apothem, that 60 gets split in half to be a 30-degree angle. So this is a 30, 60, 90. So the little formula for this, you have your short leg, you have your long leg is your short leg times the square root of 3, and then your hypotenuse is just twice your short leg. Now, really all we need here is this, and if I know this is 4, I literally just multiply that by the square root of 3. So that's going to be my apothem. Now, we're just going to ask you guys to round these to the nearest tenth when you're working on these problems, so we're not going to worry about leaving it in radical form here. So I've got everything I need to do this real quick. So surface area here, I need to complete the area of the base, and then I'll need 2 of them, and then we'll just add that to the lateral area. So area of the base is 1/2 the apothem, which is that 4 radical 3, times the perimeter of the base, which we already had to calculate for the radical area. So this is 48. Okay, so let me just do a quick, I'm going to leave it in radical form just for 1 second so I'm not rounding it multiple times when I get my actual answer. So I'm going to do 1/2 times 4 times 48. So this is going to be 96 radical 3 for the area of one base. Okay, now when we actually go ahead and write the answer, I'm going to take it out of radical form by including the square root of 3 in my calculation. So for my surface area, we already calculated the lateral area, so that's the 576. That's all the 6 rectangles wrapping around there, plus 2 bases, so 2 and then 96 radical 3 was the area of one base, so we need 2 of them. And then again, I'm just going to grab my calculator and go ahead and type this in. 576 plus 2, and then I'll just put this in parentheses, 96 square root button of 3, and go ahead and hit equals. To the nearest tenth, that's just going to do 1 decimal place. I'm going to go 908.6, and again, we're doing a surface area units squared.